All right, page 3. On this one, look at all the fractions. What is the common denominator between all of the fractions?
14x.
14x is correct. Next to every term, write 14x. Okay? The whole purpose is to get rid of each of these fractions. So here, the x's cancel. 7 goes into 14 how many times? 2. So we have 2 times 2, which makes 4. So we cancel out the 7x with the 14x, it became 2. So we have a 2 and a 2, which made 4. On the next term here on the top, 14s cancel. You have x and 3, which makes
minus 3x.
good. Over. On the bottom, what happens on this first term?
14x cancels, so it's 3.
We have 3 minus
Minus 2x.
7 goes into 14. 2 times 2x times 1 is 2x. Can anything cancel there?
No.
That's your answer.
I like that one.
And you do that, you multiply by the biggest denominator?
Yes. You have to find the common denominator between all of the fractions. And then it'll work. Okay, so we can do the same thing on the, yes.
So if the denominator is on the top didn't match the bottom, we couldn't do. Could we do like a different common denominator for? Okay.
You can do that if you want to do the top and the bottom as separate problems. You could do it that way, but if you want to get rid of everything, you have to find the one that's between the top and the bottom. Okay, so number 11, what would be my common denominator for this entire problem? 3x squared is correct. Thank you for being quiet. So we write 3x squared next to every single term. We are doing this the same way as we just did number 10. So on the top, this x cancels with one of these. So I'm left with 3x and 8y, which is 24xy on the top. Go to the denominator. 3x squared cancels, and I'm just left with y. And that's a minus sign, and I cancel out the 3's and an x with an x, and what am I left with? 2x. Can I factor or do anything there? No, that is your answer. 24xy over y minus 2x. Okay, moving on to number 12. You need a common denominator. Okay, first thing we would do is factor this. When I factor this, I get x plus 7 and x minus 2. That adds to be positive 5, multiplies to be negative 14. So what is my common denominator going to be on this problem? X plus 7, x minus 2. So I write that for both of these, x plus 7, x minus 2. My first one did not change, therefore it stays x squared minus 5. What am I missing on my second fraction? X minus 2. So I have to multiply the top and the bottom by x minus 2. Since there are two x plus 3, x minus 2's there, we need to do your box or FOIL. Okay? We talked about in our head how we can kind of do this in our head now, hopefully. But when we do this, x times x will be x squared. 3 and negative 2. What do those add to make?
Negative 6.
3 and negative 2 add to make 1, right?
Yeah.
So that's going to be 1x or x. 3 times negative 2 makes a negative 6. You can do your box or FOIL though, and you don't have to do the shortcut way. What do I have to do with this subtraction sign? How do I do that? You distribute it to everything here. So this is a minus and a plus, and then I can change that to a plus. When we go through here, x squared minus x squared goes away. There's no other x's, so I have a negative x, and negative 5 and positive 6 makes a positive 1. Is there anything I could factor or do to make it so that something can cancel? No, so that's my answer. Negative x plus 1 over x plus 7 and x minus 2.
This also shouldn't be a negative 11. Oh, never mind.
Okay, we're good? Okay. Are we ready for 13? Okay, what is my domain going to be on this? All reals except, very good, x cannot equal 1 over 7. Whatever would make the denominator equal to 0 is the only number that will not work. If you are not sure about that, all you have to do is take that denominator and you set it equal to 0 and you solve it. Oops. And then we don't have to divide by 7, so I find 1/7. So it's all reals except for 1 over 7. That's the value that would make the denominator 0. Okay, on 14. First you check if you can make these so that they make a true statement. If I do that, if I'm just looking at this part right here, x plus 7 over x plus 7, x minus 7.
You can make them true.
When this cancels out, those cancel, right?
Yeah.
If there's nothing on the top, what's there? A 1. So I have 1 over x minus 7 equals x minus 7. Is that a true statement?
No.
No. Therefore, this answer is never. If it was true, let's say that we ended up getting x minus 7 equals x minus 7. What would the answer be then? Not always. Sometimes. Because, why is it sometimes?
Because it can't equal.
It couldn't equal 7 or negative 7, because that would make a 0 in the denominator.